A great day to one and all. I am Mr. Kim JC Ensho, and today I give you problem number 4. Consider a square with side 8 centimeters. Connect the midpoints of the 4 sides to construct a smaller square. What is the area of the smaller square? Please pause this video if you wish. Give this problem a try. And if you have the solution to this problem, continue the video and let's see if you have the same answer as I did. So are you ready? I hope so. So for this one, let's say you have this square, and when we speak about a midpoint, it is actually a point that divides a certain side of a square or a certain segment into 2 equal parts. So if I have this point here, then this segment here is equal to the length of this segment as well. And so if I have here the 4 midpoints, and if I connected them by line segments, I form this smaller square. And by the way, the side of the larger square is 8 centimeters based on the problem. Let's say this square has vertices A, B, C, and D, and that the smaller square determined by connecting the midpoints have vertices E, F, G, and H. So we are asked, what do you think is the area of this smaller square? What is the area of square EFGH? And that is the question that we are trying to answer. Now, from here, the key here is drawing auxiliary segments. But before I draw the auxiliary segments, there are many ways of doing this problem. Others would do it using the Pythagorean theorem. Others would doing it in other means based on the geometric properties or the algebraic properties that they know. But for this solution, for a multitude of solutions possible, what I'll be showing you is how to solve it by drawing auxiliary segments. So here, I will connect the opposite vertices of EFGH. So I have there EG, and I also draw segment HF. It's the diagonal of EFGH. And by doing such, we could see that square ABCD is divided into 8 equal non-overlapping small triangles. And these are the following. We have here 1, 2, 3, 4, 5, 6, 7, and 8. And from here, we could see that square EFGH, this one, is composed of 4 small non-overlapping triangles of the 8 parts of square ABCD. And this leads us to the question, the area of square EFGH is what fraction of that of square ABCD? If you answered 1/2, you are actually correct. Because if you could see, since EFGH here is 4 out of the 8 total parts, then the area of EFGH is 4/8 or 1/2 the area of square ABCD. With such, so area of EFGH is 1/2 the area of ABCD. And we know that the side of square ABCD based on the problem is 8 centimeters. And to get the area of a square, the formula is side squared, or you just multiply the side to itself. Hence, the area of EFGH is equal to 1/2 the square of 8 centimeters. And 8 centimeters squared, that's 8 cm times 8 cm, that's 64 centimeters squared. And 1/2 of 64 centimeters squared is 32 centimeters squared. Hence, we could say that the area of the smaller square, in this case, EFGH, is 32 centimeters squared. I hope you got the same answer as I did, but if not, then it's still an avenue for us to become better, or at least we know the solution to this problem. And before I end, let me give you our quote of the day. Math: mistakes allow thinking to happen. There's nothing wrong if we make mistakes at some point, but what is more important is we learn from them. And by learning from our mistakes, we become better individuals. With that, TYVM, thank you very much, and a great day to one and all.